Today we will see DSP preliminaries and applications. So first is sampling. So what is sampling? Sampling is nothing but a sample is a value or the set of values at a point in a time or in a space, and a sampler is a subsystem or the operation that extracts samples from a continuous signal. So theoretically, ideal sampler produces the samples equivalent to instantaneous value of the continuous signal at desired point. So sample is nothing but a value or the set of the values, and sampler is nothing but the subsystem or the operation which extract the samples from the continuous signal. So the signals we use in the real world, such as our voice, are called as the analog signal. So our voice is analog signal. To process this signal in computer, we need to convert the signal into the digital form. So analog signal is a continuous in both time and amplitude, and digital signal is discrete in both time and amplitude. So, to convert a signal from continuous time to the discrete time, a process called sampling is used. The value of the signal is measured at certain interval in that time. So what is sampling? Sampling is nothing but converting the signal from continuous time to the discrete time. Here each measurement is referred as a sample. So the analog signal is also quantized in amplitude, but the process is ignored and it will be explained by some other group. So sampling means what? It is nothing but the process of converting the continuous time analog signal, suppose xa of t, into the discrete time signal by taking the samples at discrete time intervals. Sampling the analog signal makes them discrete in time but still continuous value. Means analog signal is converted into the discrete by using the sampling method, but it is in continuous, but still these values are continuous. If done properly, that is, if Nyquist theorem is satisfied, sampling does not introduce the distortion. So what is sampled values? Sampled values means the values of the function at sampling points. So what is sampling interval? The time that separates sampling point is nothing but the sampling interval. If the signal is slowly varying, then the samples per second will be required than if the waveform is rapidly varying. So the optimum sampling rate depends on the maximum frequency component present in the signal. So what is sampling? Sampling is nothing but converting the analog signal into the discrete signal. What is sampled values? It is nothing but the value of the function at the sampling point. And what is sampling interval? It is the time which separates the sampling points. Now the analog to digital conversion is basically of the consists of two process. One is sampling and the other one is the quantization. Sampling means converting continuous time analog signal to discrete time continuous value x of t. So it is obtained by taking the samples of x of t at discrete time interval ts. Now what is quantization? Quantization is nothing but converting the discrete time continuous value to the discrete time discrete value signal. So basically analog to digital conversion consists of two main steps, sampling and quantization. Sampling converts continuous time signal into discrete time continuous signal, and quantization converts discrete time continuous signal to discrete time discrete value signal. In many applications, it is useful to represent a signal in terms of sample values, which is taken at appropriate spaced intervals. So the signal can be reconstructed from the sampled waveform by passing it through an ideal low-pass filter. To ensure the reconstruction, the original signal must be sampled at an appropriate rate as described in the sampling theorem. So analog signals continuous in time and amplitude, for example voltage, current, temperature. Digital signals discrete both in time and amplitude. For example, digitization of the analog signal, attendance of the class, these all are the digital signal example. Discrete time signal is nothing but discrete in time but continuous in amplitude. So, the sampling can be done for functions varying in space, time, or any other dimensions, and results are obtained in two or more dimensions. So, the sampling frequency or the sampling rate, that is Fs, it is the average number of the samples obtained in 1 second, that is samples per second. So, frequency is equal to 1 by T. Now, what is sampling theorem? Sampling theorem, in that first concept is sampling rate or the sampling frequency. What is sampling frequency? The rate at which signal is sampled, expressed as the number of samples per second reciprocal of the sampling interval, that is Fs, sampling rate is sampling frequency is equal to 1 by Ts, that is reciprocal of sampling interval. Now Nyquist sampling theorem. The sampling is performed at a proper rate. No information is lost about the original signal and it can be properly reconstructed later on. So what is the basis of this theorem? Sampling is done at proper rate. There is no any loss information and the original signal is reconstructed properly. So what is the statement? If the signal is sampled at a rate at least but not exactly equal to twice the maximum frequency component of the waveform, then the waveform can be exactly reconstructed from the samples without any distortion. So Fs is greater than equal to 2 times F max. Sampling theorem for the bandpass signal. If analog information signal containing no frequency outside the specified bandwidth, it may be reconstructed from its samples at a sequence of points spaced 1 by 2 seconds apart with zero mean squared error. The minimum sampling rate, samples per second, for an analog signal bandwidth is called Nyquist rate. So, what is Nyquist theorem? According to Nyquist theorem, the sampling rate must be at least 2 times the highest frequency contained in the signal. So, here this diagram shows Nyquist sampling rate for low pass and band pass signal. In first diagram, it is low pass signal. So, the signal having a frequency, low frequency is passed, and in second diagram it is a band pass filter, so it passes the frequency, it passes some limited band frequency. Now this figure shows recovery of the sampled sine wave for the different sampling rates. So in first diagram, the Nyquist rate sampling is Fs is equal to 2f. In second oversampling, so Fs is equal to 4f, and in last diagram undersampling, that is Fs is equal to f. These three different diagrams for different sampling rates. This diagram shows the sampling representation. How sampling is done? So for sampling, first obtain the signal values from the continuous signal at regular time interval, which is sampling time, and its reciprocal is Fs, that is sampling frequency. So first we have to obtain the continuous signal at regular time interval, that is Ts. Ts is nothing but the sampling time, and its reciprocal is Fs, that is sampling frequency. Result of this process is sequence of the number. So discrete time signal will be denoted as x of n, where n is the index. As the sampling interval Ts is defined, sampling just extract the signal value at all the integer multiples of ts such that the equation is given xn equal to x of n by n minus ts. So how sampling is done? First, ts is nothing but the sampling time, that is continuous signal at regular time interval, and reciprocal of this is fs, which is nothing but the sampling frequency. So the discrete signal is denoted by xn, where n is index. The sampling tool. In practice, the continuous signal is sampled using analog to digital converter, that is ADC, a device with various physical limitations. This results in derivations from the theoretically perfect reconstruction, collectively referred to as distortion. So analog to digital converter tool is used for the sampling.